Good evening, everybody, and welcome to another recording of vBrownBag. We are kicking off a new series tonight with Britton Johnson. He's going to take us deep into the bowels of NSX-T. Tonight we're starting off with an introduction, and we'll hear more about the deeper functionality in following weeks. I'm going to hand it over to Britton in a moment, but before I do, a few housekeeping notes. We are recording this live, but we want you to interact with us. So if you're in the audience tonight, please feel free to ask questions in the Q&A. We have a chat as well, but I'm going to be watching the Q&A specifically. Also, I'll be watching Twitter. So use the hashtag vBrownBag as well to interact with us there. I'll be catching up with that, and I'll relay your questions to Britton. Before I pass it over to him, I want to mention that we have other shows as well. If you love vBrownBag and once a week does not get your fix, check out our other times as well. With that, I will hand it over to Britton, and he will give us some NSX-T goodness. All right, let me make you presenter.
I just have to start.
All right, go ahead.
Hopefully you got it.
I do.
All right. Thanks, Ken. It's good to be back on vBrownBag. It's been a couple of years, and it's always a good time. So this presentation series that we're starting is sort of a continuation in the spirit of the series that Mr. Tim Davis did a couple of years ago, where he kind of dove deeply into the NSX for vSphere and covered, everything from A to B with that particular product set. So since VMware is sort of moving to the next generation platform of NSX, which is NSX-T, so we thought, let's dive into this, and we wanted to kind of make it very focused around what the current VCP exam is testing for. So that's why I'm sticking. Most of this is going to be based around version 2.4, maybe with some 2.5 stuff in there, and we'll probably maybe by the time we get all of these done, but the potential exists that later this summer we'll do a follow-up with 3.0 when 3.0 is released. But for the time being, this is sticking around 2.4 for very specific reasons, and that is why. Let me try this here. Okay, who am I? Again, my name is Britton Johnson. I'm a VMware NSX Senior Solutions Engineer for the healthcare market for VMware. So that means I specifically focused on customers in the healthcare industry, large university, hospital systems, healthcare providers, that kinds of thing. I'm in the vExpert program. If you're not familiar with the vExpert program, it's sort of VMware's own, user community-driven led group of people who are, evangelists for what VMware products and what we do. You don't have to be an employee to be in it. I became a vExpert before I started working for VMware. It's an excellent program. There's an application process. Just go to vexpert.com or vexpert.vmware.com to look more into that if you're interested. If you're a blogger, if you're somebody who promotes all things VMware, you should certainly look into the vExpert program. I have a bunch of certifications, and I'm trying to renew and re-up all of them on the latest NSX-T stuff. Sadly, I sat the latest NSX-T exam once with almost no prep time just to go see what it was like, because there was only one time slot open one day, and I just went and did it. And I did fail it, but just barely. So, hopefully after all of this prep for giving these talks, I'll be able to go in and sit it again and hit it out of the park. So, and shameless plug for my podcast. So, there's always that. All right. So, agenda for not just today, but for the entire series. The goal really is to today kind of be an intro and an overview of the core components and capabilities of NSX-T, things that it can do, what it, or where it fits, use cases, that kind of thing. And sort of just the general infrastructure overview of, what an NSX-T is, how it's deployed in an environment, and where we go from there. The next following, I'm signed up to do these every other week for the next 4 weeks. And so, the next one I'll be doing is NSX-T. We're going to do a deep dive into how routing and switching works. And then we'll do a specific episode on security and distributed firewalling. And the last one, we'll talk about NSX Cloud and migration with VMware HCX, or Hybrid Cloud Extension, as that's commonly called, which is sort of a bonus add-on to NSX. It's a super powerful product, and I'm looking forward to getting more deep into HCX, because it's one of these really growing areas for VMware and things that we are deeply investing in. So learning resources, this I think is probably one of the biggest pieces of doing a vBrownBag is highlighting various learning resources. So most of the different business units within VMware have various places that you can go to learn things. The one that I have never seen a whole lot of attention get thrown around is the NSX Tech Zone. So if you are at all interested in learning anything to do with NSX, go to the NSX Tech Zone website. It is stocked full of awesome information about anything from learning NSX APIs, or just basic NSX-T information, or even NSX V to T migrations and that kind of stuff. So definitely check out the Tech Zone site. There is a really good Coursera course out there for NSX for vSphere. I'm hoping that'll get updated to T. I have not heard anything specifically about that yet, but there's an excellent resource there. And then the main thing I wanted to plug is the NSX-T install, configure, manage class. So right now, we are, a lot of people are working from home these days. The one thing I wanted to highlight is this NSX-T ICM class. It is available in an on-demand format. So if you're looking for training to do at your own pace, you can take 30 days to do it. If your employer gives you reimbursement for educational expenses, this is a really good option. And you don't have to travel. You can do it at your own pace, and you get as you go through all the labs and go through all the actual course materials, you get full credit for the class. And it's taught by one of our top really good expert NSX trainers. You'll see, if you subscribe to this class and watch it, you'll see. I mean, the guy is unbelievably good. So definitely, check that out as probably a good, next step, especially if you are on the path to the VCP-NV certification. Last thing, if you're on the path for VCP-NV 2020, go get the blueprint. This seems like a really simple thing, but it's also a very simple thing to kind of forget and overlook. If you're studying for the test and you aren't looking at the blueprint, you're likely overstudying, or you're studying the wrong things. There are sections in the exam that are listed for various parts of the product, and more than likely, as you go through things that you need to learn about NSX, they may not necessarily be on the VCP exam itself for this particular go round. So anytime you are doing an exam, especially a VMware exam, get the blueprint, study the blueprint first, so that way you know what you need to know when you go in to sit the exam, because otherwise you may just be kind of filling your brain with information that you don't necessarily need at that moment. And if you're like me, there's only so much stuff you can stuff in your head at once. All right, so I wanted to start off with sort of an analogy of NSX-V and NSX-T. I don't want to spend a whole lot of time breaking apart, the why, or what the differences are, or how is V, what is V compared to T, or is T better? It's one of these things of it's a situation that is happening, and we just kind of have to go with the flow on it. And, so this is my quick and dirty explanation, I think, of why we're doing this. So I often look at, NSX and networking in general. It's sort of, it's like transportation for your workloads, much like a car. And this is the original, 1970s-ish Mustang Mach 1. So the Mach 1, was a groundbreaking muscle car for its time. It was cool. It was fast. It was loud. It was the definition of what a hot rod muscle car should be. It was at the time, it was, really the car to have for, this kind of, if you were looking for a muscle car, you were looking at the Mustang Mach 1. It's just what it was. And so now, as we kind of move forward, this is what we're looking at next, is this Mustang Mach E. Now, I'm not trying to upset diehard Mustang fans. Sorry, Tony. The Mach E is this sort of next evolution of what, we're looking at now for the Mustang. And, it's all electric. It's 4 doors. It's highly advanced technology the Mach 1 could never have dreamed of. It's quiet. It's fast. It's smooth. It drives itself. It has advanced security. It sort of has everything the original has, because it has 4 wheels and doors and windows and locks, and it can take you places just like the original. But yet at the same time, it's got so much more. And much like the Mustang going through this transition, NSX is sort of doing something very similar. Not a lot of what you learned about NSX for vSphere is going to parallel with NSX-T. Realistically, are they both networking platforms? Yes. Will they both, allow your workloads to communicate in a virtual environment? Absolutely. But you really can't make a real direct comparison between the two, because they're different platforms for different generations, much the way the Mustang Mach 1 was a Mustang for one generation and the Mach E is a Mustang for a new generation. So it's, while they're similar, they are at their core completely different architectures, and that's not a bad thing.
So with that analogy, Britton, does that mean that network virtualization fans should keep a copy of NSX-V around and maybe put a new paint job on it and everything?
Maybe. Hang on one second.
All right.
Okay.
And Graham says also put a racing stripe on NSX-V.
That would be pretty cool. All right. So if you've been around, VMware as a customer or a partner, you've seen probably this slide. And I hate to do the architecture slides here for an educational session, but if you look at the blueprint, this is actually part of the exam. You need to understand sort of the general overall vision of what a virtual cloud network is, and how, VMware's mission of protecting, any device, any application, any cloud, how that actually works. Because, you're going to see at least possibly one question on it. And so, that's the real reason I felt compelled to include this in here, because, how we deliver on the vision of virtual cloud networking, it's the complete network virtual infrastructure delivered in software, with VMware NSX portfolio. I mean, it's a whole suite of applications. I mean, that's sort of the key thing to note. Oh, I lost my pointer on the wrong screen. As you go around the circle, I mean, all these things are connected by NSX. So, no matter what it is in your environment, and NSX touches it at some point, and we'll provide some layer of communication to it. And that's, the reason, the way we can do that, and the only way we can do that, is this can only be done in software. Providing consistent networking end to end. And doing that all in software, brings things together in a programmatical, way that it gives agility and adaptability and enables organizations to move faster. And ultimately, it allows us to also layer security built in as opposed to being bolted on, which is another real key component that you need to understand that concept, especially going for an exam. It's having that built-in security part. And ultimately, it's about building, consistency in the network and security policy, for data and applications, regardless of where they are. And so that way your security, can follow the application, and if you are going from, an on-prem data center to a public cloud, we want the ability to secure that application once and let things, move it around.
Cool. My favorite part of this slide is things. If I take the exam, if I remember nothing else, I'll just remember things.
Things, yes. It's very, very important, the things. Don't forget about the users too. They're important as well.
Yeah, sure, them too.
Yeah. Okay, this is my last architecture slide. So, and it's kind of a re-messaging of the same thing, where NSX-T is the backbone for everything. Be it virtual machines, containers, bare metal servers, and we'll talk more about that specifically in a bit. And then again, it's your bridge to native public clouds and VMware cloud destinations like VMware Cloud on AWS, or the VCPP program for all of the 4,000 some cloud providers who are part of the VMware Cloud Provider Program. So it's our way to kind of really ensure that, things are consistently applied, no matter where they live. All right. And this will hopefully be the only other NSX comparison between V and T that I will do. Because, and I want to intentionally do that because, when I started learning more about T, I wanted to so badly be able to take all of my VCIX NSX for vSphere knowledge and transfer that to NSX-T. And everybody told me, don't do that because it doesn't work. And stubbornly, as tried as I might, I still tried to do it, and they were right. And ultimately, you kind of have to just, it really works best if you, assume you don't know anything about NSX-V when learning NSX-T. But because these questions come up, this is, where I'll kind of try to address some of that. So, the common capabilities between them, yes, it's software-based network virtualization. It's in an overlay. We have a couple of different ways that we deal with overlays in NSX-T versus V. The distributed firewalling functions is still there, and it's very much API driven, which APIs were a big thing in NSX for vSphere, but they're even more in NSX-T. We'll hopefully get into that a little bit here. The main thing to kind of notice between the difference between NSX for vSphere and T, NSX-T truly is a multi-platform system. We use our own ESXi hypervisor, the open source KVM hypervisor, and then realistically, we can also protect bare metal workloads now. And that is something that NSX for vSphere could not ever do. And then the shift to public cloud integration is even more, tightly integrated than it ever could have been with NSX for vSphere. So starting, back in the day, 2014, NSX for vSphere as it came in from the Nicira acquisition, and all the way to today, I mean, we're constantly adapting and accelerating the deployment of new features and things that are coming in at a really, really fast pace. It's being internal to VMware now, it's really hard to keep up on this stuff, which is part of why I wanted to do this series of presentations, is just to force me to learn more of this and learn how better to communicate it to people. And I think the main thing to point out here is, with 2.5, we launched out the NSX Intelligence Platform add-on, which gives now, full IPS and IDS services, so that NSX is really becoming, a complete network security solution, more so than ever was before. And we still have partner integrations for security additional, but really, NSX is becoming a standalone platform in that regard. And first and foremost, to that point, NSX is a platform. It's way beyond just one product. I mean, back when NSX for vSphere was a thing, I mean, it really was just one product. And now, we've moved into where it's multi-hypervisor. We cover bare metal stuff. the bare metal part is Linux today, but in 3.0, as that is coming out, and I think this has been announced, we will be covering Windows physical workloads in the future. So, as we kind of keep advancing, we're going to keep spreading out across more and more of the network and being able to apply more and more security as things roll. On the services side, NSX still delivers the same network services it always has, be it NATs, load balancer. And the load balancing space is getting very interesting with our addition of Avi networks, which has kind of kind of being relabeled as the NSX Advanced Load Balancer. But, Avi, the NSX Advanced Load Balancer, I mean, the way that system works, from the core infrastructure side of things, it's deployed very similar to the way NSX is, where it has a management plane, a control plane, a data plane, and it's it's very analogous to the way that NSX works. And I'm sure we'll probably have to get somebody on the vBrownBag, Ken, to do an Avi deep dive if that hasn't already been done.
I don't know if it has, but we can certainly set that up.
Yeah.
You put your people in contact with my people.
Yeah, I'll introduce you to some people. Yeah. And on on the networking side, all the key changes here now is all virtual distributed switch management is done by NSX now, with the introduction of the NVDS, or the NSX Virtual Distributed Switch. And I'm going to cover some terminology updates in a bit. That's one of the biggest learning curve items when learning NSX-T, is there's a bunch of new terminology. And that's, again, also very important stuff for if you're after the exam. And yeah, so like in days past, the virtual distributed switch part of vSphere, where you connect all the hosts in a cluster on one central virtual distributed switch, everything was uniform. That was controlled by vCenter. The NVDS as a construct is controlled exclusively by NSX and is owned wholly by it. So it's really placing separation between what the vSphere admin does and what the network admin does. And it's part of one of the reasons that we did that. And then, the only other networking thing I want to mention today is, today only, BGP is our only supported dynamic routing protocol in NSX-T. I fully expect that OSPF will be added in the future, but I have not seen any specific timelines on that yet. Security is still one of the strongest positions of NSX as a security appliance. We're beginning to talk more about NSX as sort of a one-off security solution, in addition to just plain covering everything. For smaller organizations who want specific security services, we can deploy NSX in a sort of a appliance mode, and allow it to do packet inspections and things like that. And then but NSX is still the standard for how microsegmentation is done best. We still apply distributed firewall rules at the virtual machine network interface level. It's tighter and closer integration than any other product in the market. And this is really sort of our, shining star, as it were, of what we can do for securing workloads. And then, tag-based security grouping is probably one of it is the best way to scale a security plan for your organization. This is the thing I'm seeing more with customers who are deploying NSX in an enterprise way. You can't really do microsegmentation in a scalable way without a good tag security plan. So even that could be a full vBrownBag, Ken. Man, I'm going to give you guys a lot of work to do.
Well, I mean, you'd be the one presenting them.
I'm not doing that.
You're giving yourself more work.
Yeah, I'll give somebody else that one to do. All right. I'm going to skip through some more stuff here because we're already starting to go slower than we probably should. Okay. APIs. NSX-T supports OpenAPI, and we do allow you to dynamically create libraries and modules in multiple languages with a tool called Swagger CodeGen. It sounds really cool, probably because it is. Swagger CodeGen allows you to, take API and do lifecycle management of it from design documentation. It basically allows conversion from, Java or Python into, APIs that NSX can ingest. And the API side of NSX is something that I'm really trying to ramp myself up more on, because it's, as you get into, software-defined networking specifically, being able to manipulate it and configure it in a programmatical way is really important. All right, so here's sort of a terminology map. So, you might be familiar with some of these if you're in the NSX for V world. And, like, we used to call things a logical switch, and we now kind of refer to them as segments. Each kind of piece of the pie, as it were, has sort of a different terminology to it now. And so that's one thing, especially if you're going through the exam topics, you need to understand the different kind of terminology mappings, because they might try to throw an old terminology at you in a question and trip you up. So just make sure you're kind of keeping on top of the lingo, as it were, and into how that's changed. So part of how this is deployed now, in the different various layers, any core NSX component that can carry virtual network workloads is effectively what we refer to as a node. So a hypervisor, be it ESXi or KVM, is now referred to as a transport node. And this is sort of a little bit different, because it's because we're not managing the network, and we're not managing things as inside of vSphere. We're not just looking at hosts and clusters and all that kind of thing. Those kind of terminologies, they still do matter, but at the same time, we also have these things called edge nodes, and then we have the bare metal nodes. So basically, anything that NSX can manage networkability or network constructs for, we refer to as a node.
Hey, Britton?
Yeah.
Can I break in with a quick question from Graham? Yeah. It's actually referring to a couple slides back, and you need to back up, but he's just wondering, when you're talking about capabilities, specifically automation, why there was no mention of PowerShell.
Good question. I'll have to get back to you on that one. And maybe my guy Cosman in the chat room, if he's there, he might be able to answer that a little bit better, because he's our automation guy. So specifically, I don't know that we've removed, I don't believe that we've removed any support for PowerShell or Power NSX specifically. It would be our variant of that. But, we are kind of moving more of the things that I have seen in terms of automation. I've seen a lot more going towards things like Ansible and Terraform and those kind of playbooks of, building things out in that sort of a structure. I'm fairly certain there is still PowerShell support, but don't quote me on that until I look it up and post it on Twitter later.
Fair enough. And Cosman is saying REST API via VRA is a lot cleaner. He's basically advocating REST APIs over NSX.
Yes, there you go. All right, I can clear my throat there for a second. Okay. So again, we have this concept now of nodes in the environment where, it's transport nodes, edge nodes, bare metal nodes, and everything that is a node is effectively a network device that is managed by NSX. And the only other kind of important thing to note is these edge nodes are sort of like what the edge services gateways were in NSX for vSphere, but like 10 times more. And we'll talk specifically in the follow-up series on switching and routing about edge nodes, because there's a lot to them. Certainly a lot more than the edge services gateways ever had. Okay, any other questions thus far before I dive into the various platform components?
See no questions, just a few comments debating which routing protocols are best.
All right. I know a lot of networking people get really, really excited about routing protocols. So, okay. So this is sort of the glance of the different components of what makes NSX work. You know, and yeah, here we are again with, you know, automation and no PowerShell listed. So again, I'm going to have to follow up on that. But, you know, these three separate but integrated planes, you know, the management, control, and data plane, you know, they're implemented as a set of processes or modules and agents residing on these various nodes. You know, it's very similar to how things are built in V, but there are some changes. We'll see that in a minute. So the management plane, you know, it provides our entry point into the system. You know, it connects, you know, it's connected to all the nodes in the system, and you know, the management plane agent effectively it can run relatively independently of the control plane, but you know, there are scenarios where its fate is shared because they run on the same host. So, you know, if you lose the host that the management plane is on, obviously there's going to be some problems there. So, you know, the management plane agent specifically is, you know, it's locally accessible and remotely accessible. It runs on transport nodes, control nodes, and management nodes for node management. On transport nodes, it may perform some data plane related tasks as well. And another good item for, you know, test takers is understanding the role of the central control plane, or the CCP, and the local control plane, the LCP, and the communication channels between them. This is for sure something you will see in an exam format. But in detail, you know, the control plane, we build a controller cluster of 3 appliances, and you know, they get secured with this open VPN mesh. Zookeeper is used as a clustering solution, you know, to maintain NSX as a distributed system, maintain the liveliness of information and participation in each node. It's the Zookeeper protocol it's used, or initialized with a container initialization framework called Moot. Moot starts a Docker container and runs, you know, Zookeeper on every cluster node. So it's you know, highly available and ensures sort of, you know, the full availability for the cluster for management. Edge transport nodes. And again, we'll get more into edges in our next installment with switching and routing. But for now, just know that these are extremely powerful and flexible network appliances. They're required for stateful services and act as the bridge to other networks. You know, they can be deployed as a virtual machine appliance, or for high throughput use cases as a physical node. And that's where the edge nodes really come into their own.
I have a question, Britton.
Yeah.
I saw the point at the bottom that the Edge transport node is not the same as an NSX for vSphere Edge Services Gateway, but is it similar in functionality, even though it's a new product, quote unquote?
It does do a lot of the same. I mean, there are similarities. I'll say that. You know, if you're going to deploy, you know, VPN services, it's going to run on an edge node. You know, much like on an edge services gateway. But you know, these nodes particularly are a lot beefier, I guess. I don't know if that's a technical term, but
you heard it here first, folks. Beefy is the VMware term.
But they can certainly run a lot more services than the edge services gateways could. So again, we'll cover those in much greater detail on the next episode.
Nice.
So I have to throw this in there because the data plane development kit, it's an important piece that is available for customers to use. But I only kind of bring this up as sort of a cautionary tale because of this one little line right here where the NVDS in enhanced data path mode on NSX. When you are deploying an NVDS in NSX-T, it sort of gives you a couple of different options. And there's this fun little button you can say, hey, let's turn this on in enhanced data path mode. And if you're not really reading the fine print, you can think, well, it must be like buying, extra strength Tylenol. It's better because it's extra. You don't necessarily want to turn this on just because it's enhanced and because it sounds better. Enabling the enhanced data path mode for an NVDS and NSX-T, what it actually does is whatever host or node that you turn that on to, it puts a reservation on the CPUs on that host, and it essentially will cripple it from being able to do other services because it's going to reserve CPU for network transmission only. And this is something that really we've seen, when a customer deploys, a bare metal edge node or network function virtualization for telecom services or ISPs. That's typically where we'll see them turn this on, or they'll have a specific cluster of hosts in the enhanced data path mode because all those machines are doing is doing network, communication, and they have to reserve their CPUs for just that. And they want it to run really fast and be really reliable. That's where it gets used. So, it's one of those things of if you're not careful and you just start turning things on, you could kind of cause yourself some trouble. So don't use it unless you absolutely know you need to use it. And Ken, if there's other questions, just certainly let me know because I'm not watching that at all.
Yeah, I got one for you here. So is the Edge node the new VTEP? And I asked that, I relay that one to you, knowing kind of that the answer would be different.
So that's
VTEPs are not.
That's sort of. Let me get to that in a second. The VTEP is now no longer. We basically dropped the V, and they're now just called TEPs. Same sort of basic idea still applies, where it's the IP address is physically assigned to the NIC of the host for managing overlay communication in the cluster. And actually, I don't actually have a specific data point on that because that's more on the switching routing side. So again, see our next episode on switching and routing and how we do things. And
that's perfect. Yeah. Leave it there. Well, it's a teaser.
Yes, teaser. So the NSX Manager appliance, what kind of changed if you were following along for the early releases of NSX-T from 2.0 to 2.3, everything was still sort of in a very split mode. And so in NSX 2.4, we actually converged the manager and the controller into this new thing called the Manager appliance. And we kind of, simplified the scale out of the environment. You don't have to have as many machines to do this, and it just sort of shrunk the footprint that NSX requires to be deployed in your environment. So this is sort of, again, that data slide that shows the various components before 2.4, and so this is what it is now and going forward, where the management and control plane have been converged into a single cluster. And it is still just a 3-node cluster. No more. You really don't need any more than 3. Once we have that, that's all we need. They do need to sit within the same IP subnet. Generally speaking, there are ways that you can do it if you, for whatever reason, if your design requires that, the management NSX managers, if you have a design requirement that they be in different subnets, there are ways to do that, but it's not necessarily a recommended thing to do.
We have a question about the Manager appliance, by the way.
Sure.
Matt wants to know, does the Manager appliance run on Photon?
Good question. Again, I'll have to look at that one. I don't believe it does. Actually, I think it's running its own other thing, but I'll tweet back at that later.
All right, you can tweet to Matt Crape.
All right. Only if he sends me Coffee Crisp.
I'll let you work that out with him.
All right. So this is sort of a high-level overview of the management control plane and data plane and how it relates to the distributed firewall. We take things in, again on the top via the UI or REST or various cloud management platforms, and roll things down. What I want to illustrate here again is, with NSX-T, the configuration is pushed from the management plane through the central control plane to the transport nodes or the hypervisor. Let's roll some more here. Right. And then as part of the cluster setup, the main way we set this up, if all three of these managers are in the same subnet, you can actually turn on within NSX itself a virtual IP that will balance the load between the three, and that way it ensures availability so that not one of the managers gets overloaded by the other. The managers will also sort of talk to specific hosts in the cloud in your various clusters, and they'll sort of like always talk to the same one just to kind of make sure that things don't get out of whack. But they will change if, of course, one of them goes down. And then again, if you wanted to do managers in different subnets, you'd either have to deploy an NSX load balancer or some sort of an external third-party load balancer, and then we can work around that way. All right. So the other thing you'll see is this idea of the simplified UI or the what we refer to as the advanced user interface. So I'm actually going to kind of roll through a little bit of a demo with this.
Question, do you demo it to people like that with a tablet sitting in the hallway?
I should. All right, do you see this?
Yes, we do.
All right, welcome to the NSX-T interface. So when you're first setting things up in a brand new environment, you'll need to kind of get very familiar with the fabric section of the system overview area. Let me jump back up to the appliances area. So this is in one of my labs that I've got built out in our lab area. And today I only have a single manager out here, but this is where you would set your virtual IP if you had three of them out here, and then that way the virtual IP manages connection to all three of them. It gives you some good feedback on the stability of the environment, how things look. And when we try to make things as simple as possible in the user interface as well, where we're going to step you through setting up transport nodes, adding NSX hosts, edges, transport zones, uplink profiles, all and the like. I think the key stuff to note here is, when you're adding nodes, you can add standalone hosts, which would be your KVM hosts, or, if you had maybe one or two ESXi individual hypervisor hosts that you wanted to add that weren't part of a vCenter, say you're onboarding a new host and you wanted to throw some NSX stuff on there first to try it out, you can certainly add an individual host. That's one of the nicer things of NSX-T is it doesn't necessarily have to be all tied to a vCenter. We will certainly manage hosts that are connected to a vCenter, but it's not really a requirement anymore. in the profile section, this is something I'll probably try to get through also in our switching and routing environment. So this is another teaser. When you're building out a new environment, you're going to set up a lot of profiles. Profiles are sort of what, some of the secret sauce that makes this thing really work, especially in a scale out environment. It's how we deploy, the TEPs, just sort of the new version of the VTEP. Those are a lot of those are managed and controlled by these uplink profiles. Network IO profiles, edge cluster profiles. You're going to spend this is probably one of the better sections if you take the install, configure, manage class. One of the better sections of that course is going through all the various profiles and everything it takes, and even just sitting in the lab and spending a couple of hours really getting deep into building various profiles and configuring them. It's really good exercises to go through.
Not to be confused with host profiles, of course.
No.
Triggered PTSD. Question about the interface in general from Graham. Is there any kind of integration between NSX-T and the VCSA web client, or is it completely separate?
It is today, it is entirely separate. So that is why, you go to, a specific environment to sign into it. vSphere is its own animal. We connect with it, and so on the node side here, when I select this vCenter, this shows me the clusters that are out there, but at no point am I really doing anything specifically in vSphere that beyond just prepping the hosts and installing the necessary components on the hosts. There's not much else that I can do from inside of here to manipulate something inside of vSphere. The general concept of transport zones is still the same. You set up one transport zone, and if you're a multi-tenant type provider and you want to ensure communication between multiple transport zones, it does not happen, then you would set up a specific transport zone for specific workloads. It's very much along the same sort of line of how things work. But in this simplified UI, the majority of things that you're going to do are going to be on this side of the screen. The advanced networking and security side, this is the other side that we refer to as the advanced user interface. And you'll even see some terminology changes here, which is, not to be confusing, but there's two different ways that we're going about this. And what this really is there's two different back-end activities happening here. So when you're on this left side of the page, kind of before this little separator line, you're in the simplified UI, and everything that you do is calling out the API policy manager interface. And conveniently in the help button here, you can go into the API documentation and study to your heart's content everything about NSX API. And I recommend highly that you do so. But anything that you do in the advanced networking and security side of things is a whole different interface on the back end. The way that it programs things is completely different. It's one of the things this is sort of how things were done pre 2.4. So if you upgrade, from 2.2 to or 2.3 into 2.4, 2.5, those components that you upgraded over will show up in the advanced view. They will not show up in the simplified UI. And that's also some stuff you might get some questions on the test about, potentially, where you say you created something in the advanced UI and it's not showing up in the other one, and why is that? All right, there it goes again. So that's just sort of the quick intro to the user interface. Any questions in this other than that one?
Not about the interface specifically. We did have another one, and it was more about overlays and VXLAN and stuff like that before jumping in. Should I just tell them, tune into a future episode?
So yeah, no, the quick answer on overlays, VXLAN is no longer part of the NSX family. NSX-T now uses a different VXLAN protocol cousin called Geneve. The simplest explanation I can give for the change is Geneve does everything VXLAN does, but better. And I will leave it to much smarter people like Paul Mancuso to explain in detail why those decisions were made.
And another question related to the interface now that you're still in it. For folks who, is there a long-term plan for those of us that started on 2.1 and upgraded to 2.4 and now have our configs only on the advanced side?
And so was the end of that question, is there a way to get them into the simplified UI?
That's what it sounds like.
Okay.
I can interpret.
I have not heard anything specific to that, but it's another thing that I will look into. Because yes, I could see that as being a very frustrating point.
Right. So I guess if we go back to the Geneve VXLAN questions, specifically, will it run over a VXLAN on the physical network? And I'm not sure if he's asking, will it be VXLAN encapsulated, or can it run on a network that's using VXLAN, say a Cisco network that is using VXLAN already?
I guess the quick answer is we don't care what the underlay is. As long as just like with NSX for vSphere, as long as we have basic IP communication between each host, we have layer 2 connectivity between each host, then that's all we need. If that layer 2, if you have a fancy enough network, like, say you're running, Cisco Fabric like ACI, we have full design recommendations for how to do NSX on top of a network fabric like ACI. And, so if you need to do that kind of a deployment, certainly can be done. But you'll want to work with either a partner who's really good at it, or even VMware itself, to kind of ensure that you're following certain guidelines when it comes to that kind of advanced deployment. All right, so real quick, because of the Geneve changeover, and this is actually good timing on that end of things. And I see I've got like 5 minutes left, Ken.
So you got as long as you want.
Oh, geez. Okay.
But these folks tuning in may only have 5 minutes. So.
Yeah. So obviously different hosts support different things. So if you're rolling this out into an existing environment and you're not doing it on new hardware, these are some of the filters you want to throw into the compatibility matrix to start searching things to make sure that your hardware will be compatible with NSX-T. Manager appliance sizing. So the main thing to note here is the extra small size is really only supported for the Cloud Service Manager or NSX Cloud. So that's where you're connecting your on-prem NSX-T deployment to NSX Cloud out in like Azure or AWS. That Cloud Service Manager basically just issues instructions out to your cloud service. And so the only time you'll deploy that extra small one is for that service only. Other than that, you're pretty much going to be using medium or large deployments for everything. Hypervisor bare metal requirements, definitely check your vSphere interoperability matrix for the vSphere side of things. If you happen to be running KVM, which I have never seen a customer running it, but and if you are, reach out to me on Twitter, because I want to know if somebody's actually using KVM in production, especially KVM in production with NSX. I would like to hear that story. And then, so these are sort of just the general guidelines for deploying in those sort of environments. These, I'm feeling time crunch, so I'm going to start to speed up. So bear with me. So hypervisor hosts are a bit less restrictive. Hardware must be supported by, via the vSphere version, but it can get a little complicated. In case it runs an Edge VMC, Edge CPU requirements, you'll want to kind of keep up on because those Edge nodes, again, can be sometimes very resource intense, especially if you turn on that enhanced data path mode, and there are specific NIC driver requirements for hosts that are running that enhanced data path mode as well. So again, not something you turn on just to turn it on. So good trivia for configuration maximum trivia for later, if anybody wants to be, quizzing each other on Twitter. And I think one of the key points to note there is the number of bare metal servers at 300. I'm sure we'll potentially see that go up, but I think we'd also like to not see it. We'd like to see more people be moving stuff into a virtual workload and get some of those bare metal old legacy applications retired. Wouldn't we all love that, Ken?
No, I thrive on the legacy.
And the other kind of key thing to note, there's the network latency between NSX management nodes. That's where, if you're getting real fancy with your NSX managers and deploying them in different clusters in different sides of the country, it's probably not a great idea. You want to keep those things close together so they can stay good and in sync with each other.
One question from Nathan wants to know, in typical production environments, do you see physical edges?
I actually do have customers that are deploying exclusively physical edge nodes. And again, for some of the ones that I have, all of my customers are healthcare related, and so they deal with really mission critical applications. And so for them, the speed and the advanced resources that they get out of having those, they exclusively run them physical. So yes, I do see a lot of that. This is just again highlighting the differences between the simplified UI that I showed in the actual demo and the advanced UI, and how we interact with these things. So talking through this a little bit more, the simplified versus the advanced, what's the real difference? The real difference again is how things are done underneath. On the simplified, everything you click is really just sort of making API calls and using the policy manager API framework, which, if you're familiar with how to do REST APIs, even a little bit, learning how to do that in conjunction with NSX-T, is like, learn NSX-T first. The next logical step after that is learning how to manipulate NSX with REST APIs. Okay, just gonna skip through some stuff here. Already showed. Okay. So again, the other kind of areas where you would use the advanced UI versus the simplified UI, is in a container scenario for OpenStack or various cloud management platforms and integrations. They will be still sending things into the advanced UI. And also for some specific distributed firewall settings for being able to turn some things off, you'll see that only in the advanced side. But the vast majority of things that you will be using is going to be in the simplified UI. And that's really where we're steering people to start, when they're creating things, making sure they're creating them in the simplified UI.
By the way, Britton, to answer one of your earlier questions, Timothy says he was just working with somebody using RHV, I'm guessing Red Hat virtualization, in production.
Very cool.
Doesn't mention if they were using NSX-T with it, though.
Okay. So these are, config supported only from one side or the other. So yeah, so like the main thing to point out here is, working with guest introspection is only supported from a simplified UI experience. Guest introspection is our sort of the way like a third-party vendor like Trend plugs in their antivirus into the environment. So that was done in, in NSX for vSphere past through specific partner integrations directly through NSX Manager. It still kind of works that way today, but the setup of that is done in the simplified UI. All right. Should we go for like a couple more minutes, or how should we wrap this up?
What you think is important is what you should include. I will invite folks, if you need to go somewhere, you can hop off, but we can record for a few more minutes.
All right.
Okay, cool.
I'll quickly run through this section and then I'm done. So ultimately, when it comes to policy management, like I said, this is sort of the next layer of NSX-T. And I see this as going forward, especially a way for scale out organizations to manage NSX-T at scale. If you're doing, thousands upon thousands of hosts, working with things in a consistent way, and with central visibility and alerts and infrastructure agnostic policy, all these kinds of things, and ongoing monitoring. These are done best through the understanding and consumption of policy. And policy anymore, doesn't necessarily just mean security policy. Policy today means everything. It's a holistic approach to applying changes to an NSX environment. And in the new declarative policy framework in the policy management API, it allows users to define what they want to get out of the system. Very much, it's very much in I want this to do that thought process when you're writing out the policy, and it makes it very simple to deploy complex constructs in NSX. And I've even heard somebody in a class say, basically telling the system, bake me a chocolate cake and it will do it. I've yet to see the actual cake come out, but it's there. So, and again, NSX policy, yeah, it is more than just security. I mean, it's, we used to define security policies and security groups and those kinds of things, and that's all we talked about. But now in policy, we can define, networking constructs, firewalls, load balancers, VPN services, third-party service integrations. I mean, we can do this all in one single document and apply it, at the click of a button. And it's really just driving simplifications and allowing scaling to our customers' environments more than ever before. So these are sort of, again, the two ways that things get applied in the environment. So the declarative side is what happens when you're doing the simplified UI, and then the imperative version is what was happening with the advanced user interface. The key thing to point here is, when you're creating policies in a declarative way, you're not limited by what order things get put in, versus in the old way on the imperative, you had to do things in a very specific order. With the declarative way, you can basically say, just I want it to do this, so build these constructs and just go, and it just does it. And so this is a view of the NSX Manager and how it applies policy from the top down. So we come in to that declarative interface policy engine layer, and it pushes things down through the manager layer into the control plane, into that realized config state. So the policy model hierarchy, the key things to note here, if you're deploying, or if you want to write a call for anything, everything is sort of written in a parent-child relationship way. So if you want to run a call on a specific port, you can know that just by looking at this tree, the tree kind of it runs everything. So if you want to run a call for a specific port, you run it off of infra segments port. You know, and also, you know, there are lateral connections here that aren't shown, but each one of these things is relative to itself and its neighbor. It's again, it's really trying to simplify the overall way that you map out your API policies. And then, you know, the only other specific thing is, you know, instead of posting things in a, you know, like Postman, you know, we're not just posting things. We do what we refer to as a patch, and a patch basically applies everything all at once. So again, one of the way things worked in the advanced API workflow, you were building all these segments out one thing at a time, and you have to do it in this order, or nothing works. And you know, and then it was really complex and really difficult, and so that's where we moved to this declarative policy management plane, where we can say and build this whole structure in one document. You know, hit apply, and it will build the entire environment. You know, in one click. And then if you want to roll something back, you can roll back the whole thing, or roll back a component of it, or change one component. And it's just one call to deploy everything. So it's a really, you know, simplified way to kind of, you know, scale out and plan your environment. And it's just, again, one single patch call that applies all this to the environment. Really, really, really powerful stuff. So, you know, and it's ultimately trying to get, you know, those API calls you know, reduced down to, you know, a single JSON that, you know, or again, what used to be 33 calls is now down to 1. So really powerful stuff that, you know, as you progress through your NSX-T journey, you know, again, first step is learning sort of how stuff all works, and the policy management and declarative policy management APIs is sort of step 2. So with that is actually all I had.
Awesome. Thanks so much, Britton. I am checking here for actual serious questions, and I don't see any, but I will give folks just a minute to get in any last questions. Tony, I'm sorry I didn't ask about weekend at Verney's, but there will be a VRNI session coming up at a future date. I think April 8th will be VRNI with Matt Just.
Yeah, and don't miss that session with Matt. He is a really, really amazing guy. He does a really nice job.
Awesome. And yeah, I am seeing thank you, great content, good session, thanks Britton, all that kind of stuff, not actual questions. So I think we will call it a night, and I will stop recording. Thanks everybody. We'll see you next time.
Yep, thank you.